This problem tells us that a student takes a 12-inch copper wire and cuts it into two unequal pieces. I'm labeling the wire in the upper right as this line, and the red mark will symbolize the place where the student cuts it. I'm labeling the piece on the left with a length of 12 minus x, which is the 12 we started with, minus however much we're cutting out, and then the right side I'm just labeling as x. The student bends the piece on the right into a circle and the piece on the left into a square. Our question asks us first, what is the domain of x? Let's begin by drawing the shapes. If we have a wire that is 12 minus x inches long and we bend it into a square, we can say that this square will have 4 equal sides. We'll say that our perimeter of this shape is 12 minus x. Therefore, our side length of this square will be 1/4 of that because we have 4 equal sides. That 12 minus x will be divided evenly among all sides. Therefore, we'll say the side length is 1/4 times 12 minus x. If you want to simplify this and multiply the 1/4 times each of the terms in the parentheses, we can say our side length is 1/4 times 12, which is 3, minus 1/4 times x. We have to make sure that that 3 minus 1/4 x is greater than 0. Now we take the other piece and bend it into a circle. We're going to say the circumference of this circle is equal to x. That's the second piece of the wire. We can also say that equals to 2 pi r. It may not be a bad idea to go ahead and solve for the radius as well. If we divide both sides of this equation by 2 pi, we can say that r is equal to x over 2 pi. We'll label that r on the drawing. However, our limitation for the circle is that the circumference must be greater than 0. This means that x must also be greater than 0. With that in mind, let's solve the inequality on the top. If we start with 3 minus 1/4 x greater than 0, and then subtract 3 from both sides, we'll end up with negative 1/4 x is greater than negative 3. To clear this fraction, we can multiply on both sides by the reciprocal of negative 1/4. The reciprocal of negative 1/4 is negative 4. When we make that multiplication, we'll have x on the left, positive 12 on the right, and then the greater than sign will change to less than. Therefore, we come up with x is less than 12. We also must say that x must be greater than 0, and therefore we put a number line with 0 and 12 marked. We'll place open circles on both, and then we'll say that x must be greater than 0, so we will go right from 0, but we must also be less than 12, so we'll go left from 12. The region between 0 and 12 will be our solution set, and we'll say the domain is 0, 12. Now we can write an equation to model the area inside of the square. Since we are modeling area, we must now try to remember the equation for area of a square. We'll say that area of a square is equal to the side length raised to the second power. This will give us 3 minus 1/4 x raised to the second power. If we want to simplify this, we can multiply that binomial times itself. We'll take the 3 times the 3 and get 9. 3 times negative 1/4 will give us negative 3/4 x. And then another negative 1/4 x times 3 will give us another negative 3/4 x. And then negative 1/4 x times negative 1/4 x will give us positive 1 over 16 x squared. Now we combine our like terms in the middle. The negative 3/4 minus another 3/4 will give us negative 6 over 4x. Reduced to lowest terms, this will give us negative 3/2 x. We'll bring down the 9 and bring down the positive 1 over 16x squared, and we'll say this is our area of our square. We can also model the area inside the circle. Since we're going for area of a circle, we must say the area is equal to pi times r squared. However, we do have an equation for radius that's x over 2 pi. So we are going to replace r with that x over 2 pi. Therefore, our area is equal to pi times x over 2 pi squared. If we square this, we'll end up with x squared on top and 4 pi squared on the bottom. Then we multiply times pi and simplify. The pi on the top here cancels out with one of the pi's on the bottom. Therefore, we can say our area is equal to 1 over 4 pi times x squared. This 4 pi that's on the bottom, I have moved away from the x squared and written it as a coefficient. However, since the 4 pi started on the bottom, when I write it separately, it must stay on the bottom. So underneath my circle, I will write that the area is equal to 1 over 4 pi times x squared. Now we can find the value of x that minimizes the total area. In order to minimize an area, we must find the vertex. But before we can find a vertex, we must add the areas together. Therefore, we'll say our area total will be the square plus the circle. We know our square's area is 1 over 16x squared minus 3/2 x plus 9. This will be our area of our square, and then we'll add that to the area of the circle. The area of the circle was 1 over 4 pi times x squared. Now we can try to combine our like terms. The only like terms we have are the 1/16 x squared and the 1 over 4 pi x squared. Temporarily, we can rewrite this as 1/16 plus 1 over 4 pi times x squared. Still, minus 3/2 x plus 9. Now, the value of x that minimizes the total area is going to come from our vertex formula. Our vertex formula says that the x value of the vertex will equal negative b over 2a. In this case, our b is negative 3/2, or if you want to write this as a decimal, we'll say negative 1.5. To get a, we'll have to use a calculator where we take 1 over 16 plus 1 over 4 pi. When we enter this expression into our calculator, we get 0.142. Now, to get our x value, we say x is equal to negative of negative 1.5 divided by 2 times 0.142. Once again, we'll need to go back to the calculator. When we round this, we'll end up with 5.282. Remember that this is our x, and the x represents how long our circle should be in circumference. With this in mind, we can now find the total area. Using the x we found previously and our total area equation, we now replace all of our x's with that 5.282. Therefore, our area will be 1 over 16 plus 1 over 4 pi times 5.282 squared minus 3/2 times 5.282 plus 9. We now enter this in a calculator. Once we enter all of our numbers, we end up with an area of 5.041. This will be square inches. Therefore, now we found our minimum area of these shapes.